Let's say an engineer named Werner Brandis at toy manufacturing company Playtronics has 100 customer orders to fill. Each order requires one component part that is purchased from a supplier. However, typically 2% of those independent components are identified as defective. If Playtronics stocks 100 components, what is the probability that the 100 orders can be filled without reordering components? Okay, so we've got 100 components on hand in our inventory. What's the probability that we can fulfill all 100 orders, that is, use all 100 components, and not have to reorder anything because none of them are defective? If one of them is defective, we have to reorder, therefore we can't fill all 100 orders. Okay, so let's name a random variable, W. That's the number of defective units in 100, the 100 that we have in inventory. Okay, and we want to know what's the probability that W equals 0. What's the probability that we don't have any defective units on hand, therefore we can fulfill all 100 orders? Okay, so out of those 100 units that we have on hand, we want none of them to be defective. Okay, we want to choose none out of those 100 to be defective. What's the probability of an individual defective unit? 0.02. We said 2% of components on hand typically are defective. Okay, so 0.02 to the 0. We want none of them to be defective. Therefore, the rest, 1 minus 0.02, would be non-defective, and we want all 100 of those. Okay, so P to the W, in this case, P to the little w, 1 minus P to the n minus w. Here we have, just so we're clear, n equals 100. Okay? So if we work this out, we should get the probability 0.1326. Okay? So if we repeated this several times, on average, roughly 13% of the time, we're not going to have to reorder because none of our parts are going to be defective. We'll be able to fulfill 100 orders roughly 13% of the time. Now let's say 102 components are stocked. What's the probability that 100 orders can be filled without reordering if we have 102 parts on hand? Okay, so let's name this random variable, let's call it x, random variable x, and that's going to be the number of defective units in 102. So we've got 102 on hand this time. We still have 100 orders to fill. So n here is 102. And we want to know what's the probability that, so let's make sure we got what's going on. We have 102 units on hand. We have 100 orders to fill. Okay? What's the probability that we can fill all 100 orders without reordering? That means that we can have 2 or fewer defective units. Okay? If we have 2 defective units, that means that we have 100 good units on hand. We can fill all 100 orders. If we have 1 defective unit, that means we have 101 good units on hand. We can fulfill all 100 orders with 101 units. If we have no defective units, if none of those 102 are defective, then that means we have 102 good units on hand, and we can fulfill all 100 orders. Okay, so we want to know what's the probability that the number of defectives is 2 or less. Okay, if we have 3 defective units in 102, that means we have 99 good units, and we can't fulfill 100 orders with 99 good units. Okay, so what is this? This is the probability that x equals 0, plus the probability that x equals 1, plus the probability that x equals 2. Okay, and we can calculate this out pretty easily. Again, the hard part is translating the problem into a random variable and these probability statements. But we know that this is a binomial problem because we have some number of occurrences that we want to pick out of some number of trials, and we know the probability of that occurrence. Okay? So here we're going to pick out 0 defective units from 102. The probability of a defective unit is 0.02 raised to the 0. The probability of a non-defective unit, 1 minus that, 0.98, raised to the 102 minus 0. Okay? To that, we're going to add 102, choose one defective unit, 0.02 to the 1, 0.98 to the 101, plus 102, choose 2, times 0.02 to the 2, times 0.98 to the 102 minus 2, which is 100. Okay? This is just arithmetic. Okay? We can easily do this combination function, multiply it by this stuff. Okay? Really straightforward to do. And if we do that, we get that the probability is 0.6658. Okay? So if we have 102 units on hand, what's the probability that we can fulfill all 100 orders without reordering? 0.6658. Okay? Notice how that's bigger than if we just had 100 units on hand. If we have 100 units on hand, what's the probability that we can fulfill all orders without reordering? 0.13. Here, if we have just 2 more units on hand, if we expand our inventory just by 2 units, the probability that we can fulfill all of our orders without reordering jumps to 0.6658.